Okay, so when you get a Sheards problem like this, first thing you can do is ignore the last clear, because when it comes to Sheards, the only thing we care about is the first blur. You can also ignore the sill. So what we have here is a patient who started at -3, and then we gave them minus lenses to stimulate their accommodation until they reached -750. So the difference between these two is 4.5 diopters. And I don't want you to include any plus or minus signs when it comes to these because we're measuring accommodation, not refractive error. So we'll just measure it in diopters. The other thing is, whenever you're doing a Sheards problem or Sheards in real life, you're usually working at 40 centimeters. So the patient is already looking at a target that's 40 centimeters away, which has a dioptric demand of 2.5 diopters. Okay, so then the patient's already accommodating 2.5 diopters to see the target, and then we're able to add 4.5 diopters worth of minus lenses on top of that. So we're just going to add them together, 4.5 diopters plus 2.5 diopters equals 7. And that's our answer. Okay, and then here's another variation of the same problem. So patient's RX is that, and they're wearing a 250 ad, still working at 40 centimeters, and it says we were able to add 8 clicks of minus lenses. So in this case, we don't even really need to worry about the patient's RX because we know we added 8 clicks of minus until they had their first blur. 8 clicks of minus is, since every click of minus is 0.25 diopters, 8 clicks is 2 diopters. Okay, so they're working at 40 centimeters, so that's still 2.5 diopters. We are able to add 8 clicks of minus, which is equal to 2 diopters. So 2.5 D plus 2D equals 4.5 D. But the thing is, the patient was wearing a 250 ad, so 2.5 diopters worth of that the patient was not accommodating. It was just the glasses. So we have to take that into account. So we just subtract that out. Equals 2 diopters. And that's our answer. So I'll explain that a little bit more. Whenever we have an add power and we're doing one of these accommodative amplitude problems, we usually end up subtracting that because add power is like bonus power that doesn't belong to your eye. So in these problems, we're trying to figure out the patient's ability to accommodate. So we have to take out the add power. In simple terms, if we have one of these problems, uh, the first thing we do is find out how much minus we were able to add and convert that to diopters. And we take that amount, we add the amount of demand from the target, which is usually 2.5 diopters because of 40 centimeters. And then if the patient is wearing an ad, we subtract the ad. And I've never seen this problem given without the ad being 250. So usually in the end, you end up canceling the add power out with the 40 centimeters and you just end up with whatever amount you added to the eye.